Hello students, now we are going to discuss about resolution of vectors. What is the resolution of vectors mean? Resolution of vector is the process of obtaining the component vectors which when combined according to laws of vector addition produce the given vector. Resolution of vector is the process of obtaining the component vectors. This point we will see component vectors which when combined means like addition, combined according to laws of vector addition, not like algebra. Here based on the laws of vector addition हम करना है, produce the given vector, it will produce that given vector. Here let us consider one dimensional coordinate system. Here in this one dimensional coordinate system, it is the x axis and it is the y axis. We will see here taking that one of the vector, this origin point is O, this is the tail of the vector and the head of the vector is P. It means we are considered vector is OP. This OP is denoted with R bar. You can write also here OP bar equal to R bar. That is the given vector. This given vector making an angle with x axis is theta. Making an angle with x axis is theta. Or here I considered with x axis, but you can take with y axis also, because of in the plane it is taken. You can take either x axis or y axis, but just our convenient they are taken making an angle with x axis only. Now when it is making an x axis, here one horizontal line can take along the x axis, one more vertical line also can take along the y axis. That then to here one line you are taking along the x direction and along the y direction also can take. From this R, here you can make one right angle triangle. See that here observe this dotted line is have this dotted line. Now here I have the right angle triangle. From the right angle triangle you can take use simple trigonometry that using first we are taking that cos function, cos theta equal to, from this right angle triangle cos theta equal to adjacent upon hypotenuse. What is the adjacent here? This adjacent is denoted with this Rx. Otherwise you can take as a OM, because of this point is M, this point is O. This adjacent value is OM. Cos theta equal to adjacent upon hypotenuse. Hypotenuse equal to either OP can take, otherwise R can take. Then here we will write cos theta equal to OM upon OP. Then cos theta equal to, here write OM upon OP means can take as a R. There have C1s. Cos theta equal to OM by R. Then OM equal to what you write? Do the cross multiplication. Here OM equal to R cos theta. This is OM. But what is the OM? In the diagram you are observe OM equal to, this is horizontal component along x axis. Okay, that's why it is denoted with Rx. But how to take the horizontal component means the which component is making an angle with the given vector, that is called as a horizontal component. Another component is perpendicular to that horizontal component, it is called as a vertical component. Here which component? Here Rx is making an angle with the given vector, that's why it is called as a horizontal component. Then it is called as a this ON is called as a vertical component. Here the length of ON and the length of MP both also same. From the diagram if you are observe, here MP, here take as a this opposite side also will find. Kaise find karna opposite side? Will take as a suitable function. What is the suitable function for this? Means sine function is the suitable. Sin theta equal to opposite upon hypotenuse. Here take sin theta equal to opposite. Opposite means PM. Hypotenuse is OP. You can take here sin theta equal to PM upon OP. But do you know OP equal to R? That is sin theta equal to PM upon R. Then here do the cross multiplication, PM equal to R sin theta. Now we find that OM value R cos theta, PM value R sin theta. This PM is called as a vertical component. This PM is called as a vertical component. This OM is called as a horizontal component. How do you write the vector in terms of rectangular components? How do we write vector? How do you write the vector means, in the diagram if you are observe better, R bar, it is the R bar equal to, this is the Rx horizontal component, Ry is the vertical component. Then R bar is resultant of Rx and Ry can take. Then R bar equal to Rx bar plus Ry bar. Then R bar equal to Rx. Rx acting which direction? In the diagram if you are observe, Rx acting in the along the x-axis. In unit vectors we are discussed any component or any vector acting along the x direction, then unit vector can take as a I cap. Any magnitude acting along the y direction, its unit vector can take as a j cap. That's why here Rx acting along the x-axis, that's why Rx I cap can take. Ry acting along the y-axis, that's why take as a j cap. So there you write R bar equal to Rx I cap, Ry j cap. Here Rx acting along x-axis, Ry acting along y-axis. So there you write R bar equal to Rx I cap plus Ry j cap. Now in this form also you can express the component of vector, or in this form also you can express the component of vector. Here Rx is magnitude, I cap will give the direction. Ry magnitude along the y direction. Y direction how can say mean? J cap represents. For example, Ry I cap have this magnitude acting along the x-axis only. For example, Rx j cap have this magnitude acting along the y-axis only. Which direction the magnitude acting, this unit vector will decide. The unit vector will decide the magnitude acting in which direction. Then here R bar, Rx value we are find it in that previous slide. See once. Here Rx equal to R cos theta, Ry equal to R sin theta. Both substitute in this. Rx R cos theta, Ry plus write as a R sin theta, where R bar composite form, that is. Here R bar is composite form of vector that. Here R cos theta I cap, R sin theta j cap, resolved form. Resolved form means in one direction or in one direction, either x direction take or y direction take, otherwise z direction also can take. But present we are discussed about plane only. That's why here taken x axis and y axis. Now that is resolved form. What is the resolved form means? What is the component acting along the x direction? What is the component acting along the y direction? That is called as a resolution of one vector in different directions. That is resolved. How it is resolved? R cos theta is acting along the x direction, saying R sin theta is acting along the y direction. But what is the given vector? R bar is a given vector. From the given vector, how much component acting along the x axis? How much component is acting along the y axis? That is represented by the resolution of vector. From this, just you find that magnitude of given vector. Here modulus magnitude of R equal to under root Rx square plus Ry square. Then here resultant direction also can take tan theta equal to Ry by Rx. How can say that? This point also will see resultant direction. it is the resultant vector r bar. Then here making an angle is theta. Here also if you are observe better, tan theta equal to opposite upon adjacent. What is the opposite? Ry is the opposite. What is the adjacent? Rx is the adjacent. Then can take tan theta equal to Ry upon Rx. This angle is making with x-axis. For example, making with a y-axis also you can take. Here taking that angle is theta 1 for example. So, there you write tan theta 1 equal to opposite upon adjacent. Here what is the opposite? NP represents opposite. Adjacent value is ON represents adjacent. Here NP, the length of OM both are equal. Do you know what is the OM? OM equal to Rx. That's why OM equal to NP. So NP plus write as a Rx upon next adjacent value ON. ON and MP both are equal. The value of MP equal to Ry. Here write Ry. That is tan theta 1 is making an angle with y-axis. Tan theta is making an angle with x-axis it is. Like that is a resultant direction. Tan theta equal to Ry by Rx can. It is with x-axis. With x-axis. Y-axis also how to find? In that previous we are discussed it is. Next, for this one example can take how to resolve the any given vector. Here taken one two-dimensional coordinate system. It is the x-axis and it is the y-axis. You don't consider x and y only. YZ also you can take or ZX also can take. But to general form based we are considered as a x and y only. Then here x-axis it is the y-axis. It is the center point is called as a origin. From the origin right side positive x-axis, left side negative x-axis. Above the origin positive y-axis, below the origin negative y-axis. You clear? This is the first coordinate, it is the second coordinate, it is the third coordinate, it is the fourth coordinate. Now these axes are divided. This xy plane is divided into that four parts. It is the first coordinate, second, third, fourth. In the first coordinate, this is O, A bar, one vector is taken. It is the tail of the vector, it is the head of the given vector. This vector name is A bar. Now this A bar, in this direction one component will act, in this direction also one component will act. These components are called as a rectangular components. One component is right side acting, one component is upward acting, that is. Here if you are observe, what is which component acting right side will see? Here this axis, x axis. That's why convenient there you write Ax. Here one component acting along the y axis. From A, one of the component acting along the y axis, there you write Ay. But here Ax acting along the positive x direction, Ay acting along the positive y direction. Here we can write that A bar vector. If the vector A bar is in the first quadrant, then it can be written as, it is in the first quadrant, then it can be written as A bar equal to, it is positive x direction I cap, unit vector is, positive y direction unit vector is j cap, negative x direction minus I cap can take, negative y direction minus j cap can take. Then Ax acting which direction? Along the positive x direction. That's why here write Ax I cap, here Ay j cap. One more component acting upward direction, that is Ay j cap it is. Next one more example see. In this only, if the vector b bar in the second quadrant then B bar equal to, it is the B bar vector. B bar vector where have means in the second quadrant have B bar vector is. But it is a resultant, then one component acting left side, one component acting upward direction. Then only the resultant always in between the two rectangular components. The resultant always existed in between the rectangular components only. Here one component can take left side, it is Bx. One component take along the positive y direction, it is can take as a By. Here By it is. Then Bx acting which direction? Observe in the diagram. Bx acting along the negative x direction. By acting along the positive y direction. There you write the vector form B bar equal to minus Bx I cap. Here Bx minus I cap, minus Bx I cap. Here By j cap, By j cap it is. It is this component acting, it is one of the rectangular component, it is one more rectangular component. It is acting along the negative x direction, it is acting along positive x direction. That's why it is a vector form for B bar, that is. That's why in the statement also you are observe, in the statement you are observe, resolution of vector is the process of obtaining the component vectors which when combined according to laws of vector addition. Here everywhere also we are following that laws of vector addition only. It is not addition of algebra, vector algebra it is. Vector algebra means only I cap magnitudes are addition or subtraction will do, or j cap magnitudes only do the addition or subtraction, or k cap magnitudes only will do the addition or subtraction. That. Next, third one is C bar vector. If the vector C bar in the third quadrant, it is in third coordinate C bar vector is. Now C bar vector in the third quadrant, then its rectangular components are act in which direction? First identify that. One of the component can take as a, it is Cx. One more can take as a Cy. One is the Cx and another one is the Cy. These two are perpendicular to each other. Cx and Cy both also perpendicular to each other. Then here Cx acting along the negative x direction, that's why C bar equal to minus Cx I cap. Cy acting along the negative y direction, so there you write C minus Cy j cap. It is a vector form for that C bar. Next, this is called as a one of the rectangular component, it is another rectangular component. Next, fourth point is about the fourth vector D bar vector C. If the vector D bar in the fourth quadrant, when it is in the fourth quadrant, then for this also we will take two components. One is the horizontal component can take, another one is vertical component also can take. Along the x direction, it is a dx. Along the y direction, the component is dy. Dx, dy both are perpendicular to each other again. But dx acting which direction? Along I cap. That's why here write dx I cap. Next, dy acting which direction? Along minus j cap. So minus dy j cap, write it. This is the vector form for D bar. It is one of the rectangular component acting along the positive x axis, one more rectangular component acting along negative y axis. It is one of the example for the resolution of vector. Next, one more see. Here one application taken. Let us consider a block. Let us consider a block on a smooth horizontal surface and pulled by a force F. making an angle theta with horizontal. Here one block taken on the horizontal, smooth horizontal surface it is. On the smooth horizontal surface block is taken, F force is applied on the block. But how the force is applied? Making an angle theta with horizontal. It is making an angle theta with the, it is horizontal, it is a vertical axis can take. Now it is making an angle theta with the horizontal, but in the question will give making an angle with vertical also. First we will discuss based on the given point. See what is the components, what are the rectangular components for the applied force. Here have the angle theta. Now this is the horizontal line, it is a vertical line. This vertical line, in the direction the force is Fx can take along the horizontal direction, otherwise it is can take as a x-axis. In the y direction, or it is can take y-axis, the component of force is Fy. Along the x direction the component of force is Fx, along the y direction the component of force is Fy. Now these two components are rectangular components, both are acting perpendicular to each other. At any diagram also we will see the rectangular components are acting perpendicular to each other. Now here have the theta. First find what is the Fx. How to find the Fx mean, it is a right angle triangle, this Fy is shifted to here. Already we are discussed one point, the vector can shift from one place to another place without changing its direction. Here this Fy acting upward direction, same vector can shift to here. If you are shifted, here one perfect triangle will be formed. This triangle also right angle triangle, here angle is 90. Their angle is 90, that is. Now Fx is the one vector, here Fy is one vector. Now it is like a resultant vector is F. From this Fx value will find and Fy value also will find. How to find the Fx? From this right angle triangle, what is the suitable trigonometric function for calculating the Fx? Here adjacent side means generally preferred the cos function. Here cos theta can take. Cos theta equal to adjacent upon hypotenuse. What is the adjacent? Fx. What is the hypotenuse? F. From this right, do the cross multiplication, will get Fx equal to F cos theta. Fx equal to F cos theta it is. Next, find the vertical component. How to find the vertical component? For calculating the vertical component, prefer the sine function. Sine theta can take. Sine theta equal to opposite with respect to theta opposite Fy upon hypotenuse F. From this right, do the cross multiplication, Fy equal to F sin theta. It is a vertical component, it is a horizontal component. Now the component of force along the horizontal, F cos theta. The component of force along horizontal is F cos theta. The component of force along the vertical or along the y direction or along the vertical is F sin theta it is. Here we get Fy equal to F sin theta. That is, it is one of the application. But this application where taken? On the smooth horizontal surface taken. The next application, if you observe, a block of mass m is placed on a inclined plane to angle theta, then the component of weight parallel to the inclined plane and perpendicular to the inclined plane. Here a mass of the block is taken on the inclined plane. Then how to take the components? First case we are done in the case of the block is placed on the smooth horizontal surface. Second one is inclined surface. Now it is here considered a mass of the block on a inclined plane. Its weight acting downward direction. Weight of the body always acting vertically downwards. Because of weight of the body always acting towards center of the earth. Now here weight acting vertically downwards, mg. Here g means acceleration due to gravity. Acceleration due to gravity. Weight is a vector quantity. Weight is a vector quantity. Why? Because generally mass is the scalar, but acceleration due to gravity vector quantity. The product of scalar and vector will give the vector. That's why. So, mg is vector quantity. Here angle theta, then mg acting vertically downwards. Here one component, one line can take perpendicular to the incline, one line can take parallel to the incline. These two are rectangular components will give. These two lines are perpendicular to each other, but one line is perpendicular to the incline, another line is parallel to the incline. So, here angle theta, this line will be mg will be extend. Here observe, it is a right angle triangle, see, right angle triangle, this angle is 90, here angle theta, then this angle is 90 minus theta, that angle is 90 minus theta. This line is perpendicular to incline, this angle is 90, but this angle is 90 minus theta, but this total angle is 90. This angle 90 minus theta, then this angle definitely theta. Sum of these two angles equal to 90 degree. That will explain once again that angles will see, it will be extend down. Here right angle triangle is formed, it is a right angle triangle. This angle is 90. This angle theta, this angle is 90 minus theta. This line is perpendicular to this incline. When this line is perpendicular to incline, this total angle is 90. This angle is 90. This angle is 90 minus theta, then this angle is theta. Here, this line making an angle with mg. Which line is perpendicular to the incline? It is making an angle theta with mg. So, this mg will be resolved. Where take the horizontal component, where will take the vertical component? The doubt will be getting. But in the previous case also, block taken, a force is applied here making an angle theta in the direction fx. Where have the angle theta? In the direction f cos theta will act. Perpendicular to this, f sin theta will act. Then here have the angle theta. Then in the direction which component act? Cos component will act. Perpendicular to this, sin component will act. That's why here we will take mg cos theta, here take mg sin theta. Otherwise, with help of the diagram also, you can take here, this is the incline, here mg acting downward direction, this angle 90 minus theta, this angle is theta. This total angle is 90 degree. In the direction, one component, here I have the theta. This is one of the component. This is the vertical component, take it is the horizontal component. This component you can shift to here. Then right angle triangle will be formed here. This angle is getting 90. Here block on this incline have weight acting downward direction mg, here angle theta, one component in the direction, this angle also theta. Here one more component acting in the direction. This component will be shift to here. that is. This line and this line both are equal. Then this component it is can take as a here angle theta, that's why it is x can take and it is the y can take. Here angle is 90. Here angle is 90. Then here angle 90 means it is adjacent and it is the opposite for theta. X is the adjacent and y is the opposite for theta. Then cos theta equal to there you write adjacent upon hypotenuse. Hypotenuse value is mg, x upon mg. There you write x equal to mg cos theta. And sine function can take, sine function taken here, sine theta equal to opposite by hypotenuse f by mg. Then f equal to mg sine theta it is. Sine theta equal to f upon mg, then f equal to mg sine theta. For theta opposite is y, for theta adjacent is x. That's why sine theta equal to f by mg, then f equal to mg sine theta can write. Here the component of weight perpendicular to the inclined plane is mg cos theta. The component of weight parallel to the inclined plane is mg sine theta. It is parallel component, it is a perpendicular component. This angle 90 that is. This is parallel to this inclined plane. Similarly, it is a parallel and it is a perpendicular component. Next, one more application see. Horizontal is completed. Next one is the on inclined plane also completed. Second one is like a simple pendulum taken. A simple pendulum having a bob of mass m is suspended from a rigid support. And it is pulled by a horizontal force F. The string makes an angle theta with the vertical. Makes an angle theta with the vertical. It is a simple pendulum. One end of the string is connected to that rigid support. At another end of the string is connected to this m mass of the bob. Bob means nothing but like a small sphere it is. Its mass can take m. Next here horizontal force is applied. When the force is applied, you are pulling towards right. When we are pulling towards right, this point is fixed, but it can move. Then it is moving in a circular path. It is moving along the circular path. The string makes an angle with the vertical is theta. When it is making an angle theta with the vertical, here your applied force is, applied force along the horizontal direction is F, and weight of the bob acting vertically downwards mg. Tensional force, it is called as a tensional force. The force developed in a string is called as a tensional force. Clear explanation about the tensional force in Newton's laws of motion will give. Just present will take the force developed in a string is called as a tensional force. Then tensional force always acting towards the point of suspension. Tensional force always acting towards the point of suspension. Now here tensional force acting, here angle both also same that. Then because these two lines are parallel, this line is same. That's why both angles are equal. Now this tension will be resolved. Here have the theta means in the direction horizontal component will act. You don't consider this line is vertical. Are you clear? Don't consider this line is vertical. Vertical means always not coming that sine function. Cos component coming or sine component coming, that is depends on theta. Here theta have, that's why in the direction cos component will come. Perpendicular to the cos component, sine component will come. It is the sine component. T sine theta it is. It is T cos theta. Resultant always existed in between cos component and sine component. It is the cos component, it is the sine component, it is the resultant. Resultant in between the rectangular components. Next, now this sphere or this bob at equilibrium. Equilibrium is nothing but the net force acting on the bob equal to 0. Net force 0 means right side force equal to the left side force, upward force equal to downward force. Then it is at equilibrium. Now, what is the right side force? Right side force is F. Here F equal to T sin theta, or T sin theta equal to F can write. Upward force is T cos theta, downward force is mg. T cos theta equal to mg can take. Then here the horizontal component of tension is the horizontal component. Here along the horizontal direction the component is T sin theta. Along the vertical direction the component is T cos theta, that is. From this they take T cos theta equal to mg. Here I have T cos theta equal to mg. From this tension will write T equal to mg by cos theta. Next T sin theta by T cos theta. For these, from these two equations write T sin theta upon T cos theta. T sin theta by T cos theta equal to F by mg. T sin theta equal to F, T cos theta equal to mg. Here T cancel. Sin theta upon cos theta, that is equal to tan theta. Tan theta equal to right F upon mg. Then F equal to take mg tan theta. By this, how to resolve any given vector you can find it is. How to resolve that given vector? Here which vector is resolved? Tension vector is resolved. Previous which vector is resolved? mg vector is resolved that. Now here we will see that any vector also, any vector, here simple pendulum taken, same thing. This pendulum is pulling by the force F, then it is making an angle theta with the vertical. Now here a force is applied. Take it. Here a tension acting. Tension always acting towards point of suspension. Weight acting downward direction mg it is. Here in the previous case the tension resolved, but in this case I will show the resolution about the weight. Weight also you can resolve that. How to resolve the weight? Along this line one dotted line just you can take. This line is parallel to length of the string. This line is the new position of length of the string. Then here angle same. Because of these two lines are parallel, this line is same. Extension of the line only dotted. That's why here angle both also same. So here angle theta have, then in the direction cos component will act, mg cos theta. Perpendicular to mg cos theta, sin component will act. Perpendicular means you can take up also, you can take down also. But mg is existed in between the rectangular components. In between means definitely will take mg sin theta downward only. Then mg in between both components. It is the resolution of mg. Or f also you can resolve. This f how to resolve? Here one line can take. They are taking the line. Here angle theta, this angle is 90 minus theta. Then this angle is theta. Because these two dotted lines are perpendicular to each other. This f resolve. Here I have angle theta in the line. Along this line cos component will act. Where have the theta in the line only cos component will get. F cos theta. In this line f sin theta will act. That is, it is the resolution of the f. Like any vector also you can do the resolution. The next one is find the magnitude and direction of the following vectors. Here some example taking. One of the vector is given, how to find the first one is magnitude and second one is the direction that. Here what is the given vector? r1 bar equal to 2i cap plus 2j cap. Two rectangular components are given in the vector. It is resolved with the resolution given vector is. But they are asking how to find the magnitude and how to find the direction. Direction and magnitude both are asking, but how to calculate, we will see that. It is along the x direction acting, this component is along the y direction will act, because I cap, here I have the j cap, it is the reason. Now here 2, the magnitude 2 acting along the x axis, here xy plane take, it is the x axis, it is the y axis. Along the x direction, magnitude 2 acting, along the y axis, the magnitude 2 acting. Resultant where you have in between the two components, it is one of the component, it is another component, resultant in between them. Okay, this angle you do not know, you leave the angle, but anyway I taken here this line, but for example you are making the line like, it is also correct, but because we do not know it is exactly mid have or where have that is. Then first calculating magnitude, how to calculate the magnitude, already we know in the previous lectures also we are discussed how to calculate the magnitude. Modulus of r equal to under root the square of the component along the x axis plus the square of the component along the y axis. Here the square of the component along the x axis 2 square, along the x axis 2, that is why 2 square plus 2 square. This value is 2 square plus 2 square means here can take 4 plus 4 also from this, that is equal to under root 8. 8 can write as a under root 4 into 2, that is 4 means 2 will come outside the root, 2 root 2 it is, the answer will be 2 root. That is calculation of magnitude. But what is the second thing? Direction, how to take the direction. Here resultant always in between the rectangular components, resultant always in between the rectangular components. Then here I have the 2, along the x direction also 2, along the y direction also have 2, x direction 2 have, y direction also 2 have. Then this angle is theta. This vector can shift, here shifted that. Then here one right angle triangle is formed. When the right angle triangle formed, tan theta equal to opposite value, here 2 means here also 2, because of both sides are same. Opposite value is 2, adjacent value also 2, 2 by 2, 2 by 2 means this is equal to 1. Tan theta equal to opposite upon adjacent 2 by 2, that is equal to 1. Then theta equal to tan inverse of 1 can write, otherwise this is 1, 1 means that is equal to tan 45 degree. Then both sides also tan functions, then theta equal to 45 degree. The value of theta equal to 45 degree. Here magnitude is 2 root 2 and direction is 45 degree. With x axis making an angle 45 degree, with y axis it is making an angle is also 45 degree, because of total angle equal to 90. For example, with x axis you get answer is 30 degree, then with y axis the answer is 60 degree, that sum of the two angles equal to 90. Next, one more question, see, find the magnitude and direction of the following vector. This is r1 bar equal to 2i cap minus 2 root 3 j cap. This 2i cap, this 2 acting along the x direction, this 2 root 3 acting along the y direction, but it is minus have, minus means negative y direction acting it is. Here taken again, it is the x axis and it is the y axis. This point is act as a origin. Above the origin positive y axis, below the origin negative y axis. Right side positive x axis, left side negative x axis also can take it is. Then here where you have that this component, x component is positive but y component is negative. In which coordinate it is possible? First verify. X positive, y negative, that is the fourth coordinate. Then the vector will take in the fourth coordinate. In the fourth coordinate, will take the given vector. Now here x value is 2, y value is 2 root 3 can take. This value is 2 root 3 up to this length can take. Then this vector is shifted to here with the dotted line will showing C. It is shifted to the vector. Then here one right angle triangle is formed. When the right angle triangle is formed, then you can find the either direction or magnitude, whatever may be. Magnitude you want, it is a right angle triangle. From this magnitude of the vector, modulus of r equal to under root x square, this 2 square plus 2 root 3 whole square also can take. Along the y direction 2 root 3 whole square. But you can write here minus 2 root 3 whole square also, because here minus 2 root 3 like also you can take. But minus whole square means minus of minus will become a plus only. That is where taken plus 2 root 3 whole square also. Now 2 square value is 4 under root 4 plus here 2 root 3 whole square, 2 square 4 root 3 whole square 3, 4 into 3 12. This value is root 16 value is 4. That is why the magnitude taken 4. Next one is the direction. What is the direction? Here angle making with the positive x axis, but in the question will ask making an angle with the positive x axis or positive y axis also. Both also will calculate here. See, first to taken making an angle with the x axis, tan theta equal to opposite upon adjacent. Opposite value is with respect to theta opposite 2 root 3. Adjacent value is 2 cancel. That is can take. Here theta value directly 60 degree you can write here. Otherwise, but here taken including the direction minus 2 root 3 upon 2 taken. But like you are taken here based on the negative sign, will take as a minus root 3 where will come, means this is a 270 plus theta like will take 270 plus theta like coordinates is coordinates will be applied here. Instead of that here can take as a here angle is theta opposite by adjacent also you can write 2 root 3 by 2 directly also. Instead of here plus just you take the magnitude also, then here 2 cancel will get as a 3. Then the value of theta equal to here tan theta equal to root 3. Then the value of theta tan theta equal to root 3 means tan 60 degree. Then the value of theta equal to 60 degree. That is the value of theta. Otherwise, in this form also tan theta equal to minus 2 root 3 by 2, that is equal to minus root 3. Theta equal to tan inverse of minus root 3, that is equal to here minus 60 degrees given that. This is R2 bar has a magnitude 4 units and makes an angle of 60 degree with the positive x axis in this negative sign represents counterclockwise sense. That is here this value 90, it is the 90, this is the 270, this value 60 you get, then this value can take as a 30. This 270 plus 30 equal to 300. For example, tan 300 value find it. Tan 300 that is equal to tan 270 plus 30. Here 27 have, then the function should change, tan will become a cot. Next plus 30 means in the fourth coordinate, from all silver tea cups in the fourth coordinate tan function is the negative, minus cot 30. Cot 30 value is root 3. Like also you can find that is. This angle is 30. This angle is 30 means then this angle 60 also you can take. That's we are write as a 60 degree. Otherwise you can take by this procedure also. Tan theta equal to opposite upon adjacent can take 2 root 3 upon 2. Then tan theta equal to root 3, tan theta equal to tan 60. Then the value of theta equal to 60 degree also can take it is. The next one is resolution of vector in a Till now we are discussed about resolution of vector in a two-dimensional coordinate system. It's mean in the plane only, at anywhere taken having the two rectangular components only. But here in three-dimensional coordinate system, how to take the rectangular components? We'll see that here previous cases taken as a either xy plane or yz plane or zx plane only, but here taken x, y and z axis. That it is a three-dimensional coordinate system, x axis, y axis and z axis also. That in this three-dimensional coordinate system, let us consider a vector OP. This is the O and this point is P. The tail is coincident at O, that is origin. The head of the vector is coincident at a P. This OP equal to A bar. OP equal to A bar. Now its components how to take will be calculated. That here this is the OP. If you observe this diagram, it is like a one square have. It is the one square have. This total diagram you are observe, it is appear as a cube, because these all sides also same only. It is a cube. In the cube only, cube means that is the 3D. In the 3D only x axis, y axis, z axis are existed. That's why here taken as a cube. Now this is the OP. Here one line taken, see that. First one is OP bar equal to OK bar plus KP bar. Here OP bar is a given vector actually. This line is taken, dotted line means we are considered this. OK. OK where have, first identify this diagram in the 2D visible, very clearly try to understand here, because of it is a 2D diagram, but explanation in 3D. That it is which plane will see that. This plane name is called as a XZ, that is the XZ plane. In the XZ plane it is taken, which vector is taken, see, this is OK vector is taken. But actually in this diagram, from this diagram you are observing OP. This OP where you have means definitely you are giving answer is that is in the XY plane, but it is not in the XY plane, that is in the space have. It is making some angle, like it is making some angle with the XY plane also, that is not in that XY plane. Now it is a OK, it is a OP. From K to P one line can take, K to P. If we are asking the question here, what is the angle between them? Your given answer is definitely that is less than 90. But here KP is normal to the line OK. Normal, it means perpendicular to the line OK. Now OP is the resultant then. Here taking on the base, it is like a baseline, perpendicular to that it is the resultant. OP will give that resultant of OK and KP, that is. Then this is the given vector is A bar, it is the OK and it is the KP. That KP acting upward direction it is. Now how to take the components? OK equal to can take, OK where have means in the XZ plane have. For this vector one component can take along the Z axis, one component can take along the X axis also. The component will take along the Z axis, that is called AZ can take it is. Along the X direction the component can take as a X. Otherwise here OQ will consider, here OT will consider that. OT and OQ are the components or the rectangular components of OK. These two are perpendicular because of X axis and Z axis both are perpendicular to each other. Here write OK bar equal to OT bar plus OQ bar. From both equations here write OK plus take as a OT plus OQ. OP bar equal to OT plus OQ plus KP. Here what is the KP? In this diagram you are observe, it is the KP. It is one of the corner of the cube. The line OS also one of the corner of the cube. This the length of KP, the length of OS both also same, and both also act in the same direction. Both also act upward direction only. That's why Kp place can write as a OS. Here Kp bar equal to OS bar. Kp place write as a OS. Here OP bar equal to OT bar plus OQ bar plus Kp plus OS bar. Now coming to the point here, A bar, OP means what? A bar it is. OQ, what is the OQ? Along the x direction. From the A, the one of the component. Along the x direction, so it is denoted with AX. Next, OS, along the y direction, so it is denoted with AY. Next, OT, along the z axis, so it is denoted with the AZ. Here write OP means A bar equal to OT along z axis, so here write AZ. OQ along x axis, so write AX. OS along y axis, so write AY. In the order will take A bar equal to AX along the x axis, AX I cap, next AY j cap plus AZ k cap. This is the vector form of the A bar vector. A bar equal to AX I cap plus AY j cap plus AZ k cap. AX I cap represents the component along the x axis. AY j cap represents the component along the y axis. AZ k cap represents the component along the z axis. Here three components are have, but previous only two components. Along x axis taken one more is y, or one is the y along is the z, another one is along z, or one is along x and another one is along z also can take. But here have these three components, one is along x, another one is along y, another one is along z also that. That's why one vector influence will act along the x axis, y axis, z axis. It is called as a resolution of vector into three rectangular components. From this, here OP square, this vector form can take. OP square means just calculating like a magnitude. OP square equal to OT square under root OT square, otherwise OP square equal to OT square plus OQ square plus OS square also can take. Here OP square equal to OK square plus KP square. This is writing from this equation. OP square equal to what you write? OK square plus KP square. OK square, OK square plus KP square. Here KP equal to OK equal to OK equal to OT plus OQ. That's why here OQ square plus OT square taken again, next to KP square as it is. But here OQ, OT, KP, KP equal to, you can take one more form also here, KP equal to write OS also. KP equal to OS taken, here you write OQ square plus OT square plus OS square also. But what is the OQ means? X. Along the OQ, AX have. Along the OS, AY. Along the OT, AZ. Those are substitute here. AX square plus AY square plus AZ square it is. Then actually here this KP means AY, OT means AZ, OQ means AX. Then A equal to under root AX square plus AY square plus AZ square. It is the magnitude of vector A in a three-dimensional coordinate system. Next, the directional cosines. What are the directional cosines? In this, it is also resolution in the three-dimensional coordinate system. The directional cosines L, M and N of a vector. For a given vector, directional cosines are L, M, N. Or cosines of the angles alpha, beta and gamma with z-axis respectively, this gamma with the z-axis respectively. If alpha, beta, gamma are angles made by A bar vector, it is A bar is a given vector, This A bar vector making an angle with the x-axis is alpha, with the y-axis is beta, with the z-axis is gamma it is. Then here cos alpha, cos beta and cos gamma, these are called as a directional cosines. Cosine angle simply direct, alpha represents direction, cos means cosine function, that is why it is called as a directional cosine. Here beta direction will give, what is the making an angle with y-axis, gamma what is the making an angle with the given vector making an angle with the z-axis. That is why these are called as a directional cosines. Here it is a given vector. This vector where you have means this diagram if you are observed, you are given answer definitely the given vector A bar in xy plane only, but not in xy plane it is in the space. This vector making an angle with the x-axis is alpha, with y-axis is beta, with the z-axis is gamma. With x-axis alpha it is, but here alpha plus beta value means generally you are given answer is 90, but here not 90 that. Here making an angle like have that vector, it is a given vector. It is making an angle with x, it is making an angle with y, that both angles are not equal to 90 that given vector, because of it is in the space have not in the plane. In case the given vector in the plane have, then alpha plus beta equal to 90, but not in the plane a given vector. Try to understand very clearly the point, it is in the space have that. Then cos alpha, the previous diagram you are observed, cos alpha, this angle is alpha actually, this angle is beta, this total, this angle is gamma. It is appear as a 180, but gamma value is not 180, it is alpha. Then cos alpha mean it is the right angle triangle. Here I have the right angle triangle this. From the right angle triangle, cos alpha equal to adjacent upon hypotenuse can take. Adjacent upon hypotenuse means ax upon a, ax upon a. Here cos alpha, this is one of the directional cosine L. L equal to cos alpha ax by a. It means in the direction ax, in the direction ay, in the direction az. Now here take one line, it is the right angle triangle. See, from this right angle triangle cos alpha equal to adjacent upon hypotenuse, then ax by a. Next cos beta, here one line will be close it is a right angle triangle, but it is not in the, this dotted line also not in the xy plane. Try to understand, this is in the air medium will come, ये हवा में आएगा ये line. Then cos beta equal to adjacent upon hypotenuse, adjacent value is ay, hypotenuse is a, it is the hypotenuse. Next cos gamma, actually z axis like have, it is the z axis in this line, normal to this x and y axis, where have the vector means it is the vector, it is the given vector, it is the az. Here one line can take, this angle is gamma. Then cos gamma equal to, it is the adjacent, it is the hypotenuse, adjacent value is az, hypotenuse value is a. Then cos gamma equal to az by a it is. Now L value, M value, N value you get. From this squaring and adding these three, cos square alpha plus cos square beta plus cos square gamma. Cos alpha, what is the cos alpha? Ax by a whole square. Cos square beta, ay by a whole square. Cos square gamma, az by a whole square. Ax by a whole square means ax square by a square, ay square upon a square, az square upon a square. Take the LCM, numerator will get ax square plus ay square plus az square, that is equal to a square. Here previous we are find it, a square equal to ax square plus ay square plus az square. Here ax square plus ay square plus az square equal to a square can take, a square cancel will get 1. Then cos square alpha plus cos square beta plus cos square gamma equal to 1 it is. Cos square alpha can write as a 1 minus sin square alpha, because cos square alpha plus sin square alpha equal to 1. You know the formula. From that, cos square alpha equal to, right, 1 minus sin square alpha. Cos square beta equal to 1 minus sin square beta. Cos square gamma equal to 1 minus sin square gamma. Then 1 plus 1 plus 1, 3. Here sin square alpha, sin square beta, sin square gamma, send right side of the equal to. Here 3, this 1 take as a left side. 3 minus 1, 2. Then sin square alpha plus sin square beta plus sin square gamma equal to 2 it is. In terms of sin function equal to 2, in terms of cos functions equal to 1. These are the directional cosines. For this, one question will take. If a vector A bar makes an angle 45 degree and 60 degree with x and y axis respectively, then angle made by it with z axis is. What is the angle made by with the z axis they are asking? It means it is equal to alpha, this value is beta. They are asking what is the value of gamma. We know the formula. Cos square alpha plus cos square beta plus cos square gamma equal to 1. Alpha value given, beta value given. Alpha 45, beta value 60. Gamma value they are asking. Then alpha value 40, beta value 60, gamma value find it. Cos 45, 1 by root 2. 1 by root 2 whole square, 1 by 2. Cos 60, 1 by 2. 1 by 2 whole square, 1 by 4. Plus cos square gamma equal to 1. 1 by 2 plus 1 by 4, 3 by 4. 3 by 4 send to right side. Cos square gamma equal to 1 minus 3 by 4. That is equal to cos square gamma equal to 1 upon 4. Then cos gamma equal to, here take cos gamma equal to under root 1 by 4 actually. But under root 1 by 4 means that is equal to 1 upon 2. 1 upon 2 means that is equal to cos 60 degree. Then the value of gamma equal to 60 degree. It is one of the question. Next one more is, if the directional cosines of vectors are 1 by root 2 and 1 by root 3, then the value of third directional cosine is. Two directional cosines given, either cos alpha can take, cos beta can take, find the value of cos gamma. It is considered as a cos alpha, it is taken as a cos beta. Otherwise you take cos beta, cos gamma also, or cos alpha, cos gamma also can take. Any two directional cosines can denote 1 by root 2 and 1 by root 3. But the third one is they are asking. Now again take the equation cos square alpha plus cos square beta plus cos square gamma equal to 1. Here cos square alpha, cos alpha value is given 1 by root 2, 1 by root 2 whole square, plus cos beta value given 1 by root 3, 1 by root 3 whole square, cos square gamma, that is equal to 1. 1 by root 2 whole square mean that is 1 by 2, plus 1 by root 3 whole square equal to 1 by 3, plus cos square gamma, that is equal to 1. Here 1 by 2 plus 1 by 3 equal to 5 by 3, 5 by 6 sorry, plus cos square gamma, that is equal to 1. Then cos square gamma, cos square gamma equal to 1 minus 5 upon 6. 1 minus 5 by 6, here have cos square gamma equal to 1 minus 5 by 6. Here take the LCM, 6 minus 5, 1, 1 upon 6. Then cos gamma equal to 1 upon root 6. This is the third directional cosine. It is about resolution of vectors. In a two-dimensional, how to do the resolve the given vector, and how to take the rectangular components in a three-dimensional coordinate system.